Hi, my name is Dalen Miller. I'm an elevator application engineer here at KEB America. Today we're in the R&D lab looking at the synthetic pretorque functionality in the F5 elevator drive. Rollback at the beginning of an elevator ride can be an unsettling experience. The KEB drive has synthetic pretorque functionality that can help to mitigate the effects of rollback. What it does is it builds up torque before the brake lifts so that when the brake releases, it holds zero speed rather than rolling back. This functionality works for both induction geared machines as well as permanent magnet gearless, although with permanent magnet gearless machines, rollback tends to be more of an issue due to the lower starting friction. KEB drives use a software called Combithis6 for programming and troubleshooting. We'll be using it today to show how you can use pretorque to reduce any sort of rollback that you're getting. Today we'll be using red for command speed, blue for motor speed, green for actual torque, and yellow for the position in order to show you how the rollback is reduced. For more information on how to connect and use Combithis6, please click the link in the description. And now we're going to use the elevator simulator to show what this looks like. As you can see, we were able to show what happens when pretorque isn't active or the pretorque gains are set very low. If there's a load on the motor, then the motor will roll backwards in the direction of the load until it has had a chance to build up enough torque to move in the correct direction. Notice how the motor moved backwards, stopped, and then moved into the correct direction. As you can see, if the pretorque is active and the gains are set high enough, typically the default values work well for many applications. The drive builds up motor torque before the brake is released so that it can hold the load rather than roll back. With the pretorque gains LC5 and LC10 set appropriately high, the torque builds up and the machine does not roll back. In the version 3.21 or higher elevator keypad, the internal pretorque is always active. However, there is another function known as the predictive pretorque which you can activate. In LC01, if you set it equal to 5, also known as closed-loop synthetic pretorque, the predictive pretorque is turned on. With predictive pretorque on, the drive determines the load in the car and then uses 90% of that value for the pretorque value for the next run in the same direction. Typically, internal pretorque is sufficient for most applications, but if desired, predictive pretorque can be used to provide additional ride quality. The sequence of events that occurs in the drive at the beginning of each run is described in the manual, and you see it here. The drive performs a phase current check at the start of the run to make sure each phase of the motor is connected. After receiving a run command, LTO2, the control hold-off timer, begins. During this period, all the gains are held low to prevent disturbances under the brake. After this timer expires, the pretorque gains become active. LTO2 should be set such that it expires briefly before the brake is picked so that the pretorque becomes active when rollback would occur. LTO3, the speed start delay, is the period where the pretorque gains LC05 and LC10 are active. Once LTO3 expires, or the external speed command starts, the pretorque period is over, and the drive uses the normal acceleration gains rather than the pretorque gains. Setting LCO1 equal to 2, closed-loop FOC, means that the internal pretorque is active.